Great, wonderful. Welcome, everyone, and thank you so much for having us here on the Austin Forum. We're very excited to be here. A lot of us are longtime Austinites at this point. We also have some great new faculty as well. So as you see, we've got 5 faculty who are presenting tonight across a range of disciplines at the university, and this is the order in which you're going to hear from each of them tonight. We're all part of this grand challenge at University of Texas Austin called Good Systems. And in particular, we're going to be talking about fair and transparent AI, particularly about socially responsible AI technologies. So Good Systems is an 8-year, $10 million university-wide grand challenge. So this is an ambitious undertaking across the entire university for really trying to think about how we design, build, and evaluate the future of responsible AI technologies. There's a URL here where you can learn more about it. And so the diversity of speakers you're going to hear from tonight gives you some sense of the breadth of this that's happening. Of course, we can only bring a small set of faculty here tonight, so there's many more who are sort of involved in this. So I'm going to be only talking briefly tonight. I'll talk a little bit of the work I'm doing in explainable artificial intelligence in misinformation. And so we're doing very brief introduction for myself and others tonight, so we can talk more about content and less about ourselves. So I'm an associate professor in the School of Information. I also work at Amazon as an Amazon scholar, and I'm one of the faculty leaders of Good Systems, which is why I'm introducing it here tonight. So I said I'm in this information school with Min Kyung Lee, one of the other speakers tonight, and not everyone's heard of this, so I just briefly say, if you haven't heard of the information school, we're the place where information and technology meet. So our faculty is very interdisciplinary itself. Our department, everyone has a PhD in something else, it seems, and we really study the intersection between people and technology, which is why problems like responsible AI, which really cross the boundary between technology and human factors, are really the sort of perfect place for us to study. So other speakers tonight include Maria de Ortega, one of our new faculty in IROM in McCombs Business School. She'll be talking about machine learning and compounding injustices. Joydeep Ghosh, one of our longtime faculty in electrical and computer engineering. He, besides being at UT Austin as the Schlumberger Centennial Chair Professor, he's also chief scientist at Cognitive Scale here in town and on the board of directors of AI Global. So somebody probably maybe a number of you here have already interacted with in professional context as well as at the university. And he'll be talking about that good AI is trustworthy AI. Following this, we'll have Min, one of our great new faculty at the School of Information, who came to us from CMU. Min's been doing a lot of great work, particularly in fair AI. So she'll be talking about 3 lessons for designing fair and transparent AI from human perspectives. And then our last speaker tonight, our closer, will be Professor Ray Mooney from computer science, one of our long-standing strengths in AI at UT Austin, and he'll be talking about the relationships between fairness, interpretability, and explainability of AI systems. So I gave my presentation for tonight the brief line of explainable AI versus information. And so I'm going to skip all slides and just show you a quick demo of something we're playing with right now at the university. So this is what we call our claim checker. Kind of looks like a Google interface that you would use to search for information on the internet. Only in this case, you might want to search for something you've heard about, a claim, and wondering whether it's true or not. So this is an example of what we call evidence-based fact-checking, where we're going to go and try and find relevant articles on the information and reason about whether this is true or not. So for example, here is some particular canned claim I have here about Tiger Woods, the golfer, about whether in the past he was serving a suspension for failing a drug test. So when we say check a claim, we just run out to Bing and we find relevant articles. And the first thing you see here is just some prediction about whether this is true or not. So there's a lot of work happening in natural language processing today where people are building black box machine learning models that are increasingly accurate in trying to predict whether a fact like this is true. But at a time in the world when many people don't believe CNN or don't believe PolitiFact, why would they believe a black box model telling them whether something is true or not? So this is where we start to really try to think about explainability. So let's scroll down and see a little bit more of the interface. I have this really zoomed in for display here. So in part, this starts to look like something like Google News. Here's a bunch of articles that were retrieved. And for any one of them, I could click on that article to see what that particular story was. But we've got a couple other things here. We've told you the source where the article was gathered from, and we've predicted something about how reliable that source is. We've also gone and for each of these articles predicted whether that article supports the claim, refutes the claim, or just an article talking about the claim but doesn't take a stance, or maybe has mixed evidence on both sides of the issue. So what hopefully a lot of people learned in school, or maybe even in a library, was something called information literacy, where if you want to check whether something you read on the internet is true or not, you should go out and collect diverse sources of information, kind of reason about what's correct about them, and sort of aggregate all that evidence together to come to a final conclusion. So in this case, we've gathered a bunch of evidence here from across the internet. We've hopefully gathered diverse sources. We've predicted something about how reputable they are and what their positions are. And you can sort of think about this as a complex weighted sum. We're just going to sum up all the evidence based on how much we believe it and what that evidence reasons about. And that's how we're going to come to this ultimate conclusion. So hopefully something like this is complementary to the kinds of information literacy skills we already practice, or help scaffold them for people who don't already have those sort of skills intrinsically. Now, you might still wonder something like, well, here's this reputation for a particular source. Where did that come from? So in this case, you can click on any of the sources. And what we're actually showing you is the training data that this machine learning model was trained on. So as simple as it can be for interpretability here, these are literally all the training examples that were seen for this particular source. And we can see how often in the past in the training data, this source got things right or wrong. And based on that, we can reason about how reliable it is. So past performance is predictive of future behavior. So if this was a reliable source in the past, we'll believe it's sort of still a reliable source now. So you can actually go and inspect, in general, the training data here to see why the sources have the reputations they do. And that's kind of a general thing about AI explainability, is often wanting to inspect the training data that a model was trained on. Now, another thing you might think about is, well, I looked at this particular story here, and the model has predicted the story as strongly supporting the claim, but in fact, it got it wrong. You looked at the story and the model just made a mistake. So we always have to design from the beginning that AI models are fallible. We shouldn't assume they'll always be correct. And we have to be able to have people override them when they make mistakes. Moreover, AI models always make simplifying assumptions about the world, and we often have more experience or knowledge or expertise that we can bring to bear. So how can we sort of combine our information with what the model has? So the simple way we do it in this case is with these sliders. So in this case, you can see the model has predicted that this article really supports the claim, but I can override it. And when I override it, you see at the top, the prediction of the model overall changes in response in real time. So one way I learn a little bit more about how the model works, the way the model becomes more interpretable to me, is through the interaction. Through interaction, I get a sense of how the model behaves by changing this stuff back and forth. Similarly, if I know more information about whether the source is reliable, we saw the training data only had 3 examples, I can also override this prediction about whether this is a reliable source or not, and again, see the model change in real time in response. Another cool thing we can do here is often when we're building systems today, we do a combination of what we call human in the loop and an automated algorithm. So maybe the state of the art in automatic fact checking is maybe only 80% accurate in predicting whether a claim is true or not, but people can do better. Is there a way we can actually call on people on the internet to help us improve the quality of the model in real time? So there's a whole sort of exciting thing that would be another talk in itself about sort of programmable access to human labor. But in this case, the model can go on the internet and ask people for help. And so in any of these cases, you could, for instance, look at, instead of the model prediction, what the human prediction was gathered from workers on the internet, where they're complementing or augmenting the model to extend its accuracy. Okay, so let me wrap up by talking about one more possibility of echo chambers. So when you're getting your news feed from Google or Twitter or Facebook, that is often maybe personalized based on things you've clicked on in the past or who you're connected to in your social network. And so the news feed you're seeing might not be the same as what other people are seeing. So you might be in some kind of echo chamber or filter bubble. And there's no way to know it because there's no visible indicator that you're in this space. Well, the tool we've shown here is potentially creating even a worse case. you might want to use a fact checker to find out whether something's true or not. But if I can override the model to be whatever I believe it to be, I can basically create my own echo chamber. So another thing we're doing that's not shown here is to take this notion of bias and try to make it visual, so it's explicit, make it interactive, and make it playful. So you might imagine this tool starts out with a neutral view of the information here, and imagine another slider here at the top that say it's in a neutral position, saying that we're kind of in a neutral view of the world. If I go and I start monkeying with all the reputations of my sources and I say all the liberal sources are very highly reliable, we can make this bias slider move to the left to show that you're going to a more liberal view of the world and remind you that you're not in the neutral default view. On the other hand, if you assign all the conservative sources very high reputation, again, we could go back and say that you're in a more conservative view of the world. So one mode of interaction is as you inject your knowledge, your beliefs into the tool, we don't just make this a silent echo chamber, we make you realize that you're out of sort of this default view of the world. The more playful thing to do in the other direction is imagine in the privacy of your own bedroom, you might wonder what it's like to be a raging conservative or a raging liberal. So you can grab that little bias slider and drag it all the way left for liberal or all the way right for conservative, and we'll update all the sources' reputations. So all the conservative sources will become very reliable, or all the liberal sources will become very reliable. So in the context of good systems, this work we're doing at UT Austin on responsible AI, it's very easy to make general ideas or general algorithms about how to make something interpretable or explainable. But if we don't really ground it in the context of a real world problem, it's easy to sort of do navel gazing. So in this case, besides trying to help curb misinformation, disinformation on the internet, we're using this as a motivating grounding application to help us learn more general lessons about how to build explainable AI systems. So with that, I'm going to wrap up my portion of the talk and turn it next over to Maria.
Thank you, Matt. Hi, everyone. I'll share my screen here. Okay, so now you should be able to see my screen. And today I'll be talking to you about machine learning and compounding injustices. And in recent years, we have seen a lot of discussion that is precisely what brought us here today around the risks that artificial intelligence may replicate humans' biases. And this has been one of the big areas within the discussion of AI ethics that has received a lot of attention. And when we look at a lot of the conversation in this space, one of the elements that is common is the point on replicating the bias. And so what I'll be focusing on today, and if you take one thing as today's lesson, is the fact that AI may not only replicate human bias, but it may also compound it. And this is something that can really inform our conversations around the risks of bias in machine learning and whether we're simply talking about a tool or a context in which we're saying, well, it is representing the world and this is the world as it is today, so what are we going to do? Or whether it may also compound and amplify biases. And I will be presenting to you some work in the space of human resources and automated recruiting and hiring. This is a space where we've seen that a lot of machine learning is starting to be used. And we have seen how a lot of people have been very concerned about this, right? Because there's the potential risks of bias embedded in these technologies, while other people have seen it as an opportunity to reduce the bias ingrained in our current recruiting practices. So this conversation is what led me and my collaborators into the space, who are from Carnegie Mellon, UMass Lowell, Microsoft Research, and LinkedIn, to ask the question, can we characterize the risks of incorporating machine learning in hiring and recruiting pipelines? And what our findings are through a large-scale study that I'll be showing to you are mainly three elements. So the first one is that we found a gender accuracy gap in this large-scale study that we conducted. We also found that scrubbing explicit gender indicators, such as gender pronouns and words like Mr. or Miss, which grammatically can lead you to infer gender very easily, is not equivalent to gender blindness. And we found a compounding imbalance effect, which, as I said, is if there's one takeaway from today, that would ideally be it from what I'll be telling you about in the next 10 minutes. So if we're building an automated recruiting tool, what would we like this tool to do? If we're looking for a computer programmer, we may want a tool that helps us identify that a candidate is a software engineer with experience in Java, Python, C++. And of course, we wouldn't want the fact that their name is Jane, for instance, to influence the probability that we see this candidate as a potential candidate in our search. The challenge here is that even if we obfuscate this information, there's other information in the CV, for instance, or in someone's biography, such as the fact that someone was softball team captain at a historically Black college, that can lead the algorithm to infer that with high probability, this candidate is a Black woman. And again, we would not want this to influence the probability that this person shows up in our search for a computer programmer. This is a challenge that becomes increasingly more difficult as the data that is used is more and more unstructured. So as an example, one of our online presence and our website is increasingly used by recruiters to determine what do we do, may we be a good fit for a job. These, by the way, are all of the collaborators in this work. And so as the data is more structured, what are the risks here? So what we did was we said, okay, what is the simplest task that an algorithm needs to get right if we want to have an automated recruiting tool? And we said, well, these would be predicting what someone's occupation is before the algorithm can say if they're good at their job, if they're not. And so here we constructed a data set of 400,000 online biographies, which, by the way, the code to reproduce the data set is available online. And here we said, well, the goal is, for instance, in this example, to use the orange text, the text highlighted in orange, to predict that this person is a professor. And we have 28 possible titles, and we use the gender pronouns. So these are biographies written in third person to be able to characterize what the gender effect in the accuracy will be. A limitation here is that we're only looking at he and she pronouns. So we're only looking at the effects on binary gender. How these technologies affect non-binary individuals is another question that is very important and we do not address in this research. So this is a little bit of the distribution of the biographies in our data set. As you see, us professors really like having our biographies online. And what the learning pipeline that we study is basically all you need to see from this slide is we have the biography, then we explore different semantic representations and learning algorithms, and the objective of the tool is to predict the occupation. The first question that we asked was, how will the predictions change if explicit gender indicators are swapped? And this is motivated by research conducted in 2004, in which Bertrand and Mullainathan sent fake CVs that looked identical except for the names of the people, and that would lead the person receiving the CV to infer that the gender and race of the candidates was different, and they measured the effect. This was my biography at the time when we started this research, and the algorithm predicted that I would be a teacher. If I were to swap my gender pronouns to be male gender pronouns, then the prediction would change to say that I am a software engineer. And this is something that we saw happening at scale. So here what we're seeing is how in cases in which there's an incorrect prediction when people are using their gender pronouns, but there would be a correct prediction if they just swapped their gender pronouns and left everything the same. So for instance, women rappers are incorrectly classified as models, but would be correctly classified as rappers. And men paralegals are incorrectly classified as attorneys, but would be correctly classified as paralegals if they were using women's gender pronouns. What happens beyond the gender indicators? Of course, some of you are thinking, well, just delete the gender indicators. Terrible idea to have them in there in the first place. Well, what I'm showing here is what we term the gender accuracy gap. And so in the x-axis, you're seeing the percentage of women in each occupation in our data set. And in the y-axis, you're seeing the gap in true positive rates, basically the gap in accuracy. And if there was no gap, you would see everything lying in a horizontal line. But what this correlation means is that the classifier is more accurate for women in occupations that are already predominantly female, and more accurate for men in occupations where men are the predominant group. The reason why this is important, well, not precisely surprising from a statistical perspective, is because this means that the gender imbalance will be compounded. So what happens is if the fraction of women initially is less than half and the gender gap is negative, the algorithm has a higher accuracy for men than for women, then among true positives, women are going to be further underrepresented. And we can relate this to a notion of indirect discrimination that is termed compounding injustice. This is what is happening here is that the initial imbalance, in cases when the initial imbalance constitutes an injustice, what the algorithm is doing is it's making a prediction that is informed by and compounds that injustice. So let's just look at a toy example of what that compounding effect means. In our data, 14.6% of surgeons are women. But the algorithm correctly identifies 71% of men surgeons as surgeons, whereas it only identifies 54% of the women. So among the true positives, among those that we would be saying, okay, in the context of automated recruiting, we would be sending an ad that is relevant to them because that's their occupation, then women would only be making up 11.6% of that group. And what we see here is simply, it happens across the different representations that I discussed. I don't need to go into the technical details here. But what we see here is it happens across the different learning algorithms and representations, and scrubbing the explicit gender indicators mitigates the problem, but doesn't solve it. And we can think of this as analogous to what happened in orchestra auditions, where musicians were asked to play behind a curtain so that the judges wouldn't know what the demographics of the musicians were. What happened was that was not enough to mitigate gender bias because it was still possible to hear the shoes. And so when someone was wearing heels, they would infer that it was likely a woman. And this is analogous to what you can think of the algorithm doing when you try to scrub the explicit gender information. So to summarize, we found a gender accuracy gap in this large-scale study. We found that scrubbing the explicit gender indicators was not enough to mitigate the bias. And we found that this bias had a compounding effect. It was not only replicating the bias that was in data. Thank you very much. And with this, I will pass it on to, I think, Joydeep. You were going next?
Yep, I am. And you should be all able to see my screen. So thank you, Maria, for that wonderful talk. So I'm going to give a contrastingly sort of high-level talk here. I'm representing good systems. I was tempted to say my talk would be good systems is trustworthy AI, but that was way too big a gap to bridge. This is already a leap of faith. So let me try to pause it. And I want to just give you some thoughts about how to think about trustable AI as a way of trying to get to good AI and some of the things to watch out for rather than a specific solution. So, so firstly, well, you have good systems, and of course, you can have plenty of good systems that have no AI in it. So you can think about maybe a a scheme for deciding whom to give vaccines first, or an admission scheme that may not have any AI in it. But I think for this audience, we are a lot of us are interested in AI. So you might have heard about the notion of AI being ethical. So I was very curious about what this term means, because as a fan of Asimov a long time back, he came up with the 3 laws of robotics, right? And I very soon find out that now his laws are considered to be non-ethical. So if you're interested in that, you can Google for it. So people have found all sorts of ethical issues with the 3 laws, which when I read as a college student seemed perfectly reasonable to me. So clearly what is ethical is A, challenging, and B, maybe the concept also evolves over time. So it turns out that a variety of governments, nonprofits, institutions, etc., have come up with ethical principles. So I work with the World Economic Forum. They have 5 principles as well. So a recent study by Ernst & Young came up with 175 distinct sets of principles for what it means to be an ethical AI. And many of those principles are very conceptual and at a high level. So for example, AI should do no harm, or it should work hand in hand with humans. You have to figure out what that hand means, but and so on, right? So these are very high level conceptual things. It's always good to think in that level of abstraction. But at some point you want to say, well, how do I operationalize this notion about what it means to have an ethical AI system? And that's where you come to more approaches which are much more grounded, at least seems somewhat tractable. But there's a big gap. And I call it the responsible AI gap, the gap between the notions for what it means a system to be ethical versus or responsible. And the 2 terms I see mostly being used is trustworthy AI and responsible AI. So responsible, I think, has a slightly more ethical connotation. So you can think about, corporate responsibility. You can think about social responsibility. Well, trustworthy, in some sense, you could think about, AI, it's doing what it's expected, what I'm expecting it to do, but I might have some evil things, at the back of my head as well. So, so there's, I think the responsibility section is, but anyway, both these concepts, in some sense, are where you can actually look at that and say, well, how do I build a system that is responsible or trustworthy? If I can define the main components that are in such a system. Okay, so, so I just mentioned that I'm also chief scientist at Cognitive Scale, which is one of the sponsors of this forum. So I won't talk about any of our products, but in terms of trusted AI, we think of it in terms of these 6 components. And really, the importance of each component might differ from case to case, but typically these are the 6 components we consider. So one is, of course, explainability and transparency, and the second is bias or fairness. So those are the 2 topics of today's forum. Also, there's this notion of robustness, and you'll see pretty soon that all these notions are tied. So, so it might seem that something is fair, but it's very easy to game the system and make it unfair, right? So the system is fair, but not robust. And then Maria gave an example about the surgeon. So that's unrobust, which is in some sense lack of robustness over data drift over time. So maybe 50 years back, it was okay to assume that a surgeon is a guy, or most of the surgeons were guys, but that's not the case anymore, right? So there's a lack of robustness, which in this case, robustness due to data drift, or your data you use being outdated, that is causing a certain kind of bias. In certain areas like financial applications and so on, compliance is a big concern of building a reliable AI system. In fact, I've come across people who rather not even deploy a system, even though it shows some good accuracy, because they're not 100% sure that it's going to meet all the regulatory requirements, because that is a much larger penalty for you. And the fifth bucket is various types of data risks, including privacy leak risks, data poisoning risks, and so on. And finally, when we think about trusted AI having these 5 components, we should never let go of the fact that we are, of course, interested in this AI being useful. So for like a AI used as a predictive model or prescriptive model, we are interested in its effectiveness, for example, accuracy. So if something is guaranteed to always give you the correct answer, you may not you may not be worried about the other 5 so much. But any real-life system, there will be some errors, and that's where the other things come in play. But what this means is there's a trade-off. You might be able to live with a little bit lack of robustness if it gives you much higher performance, and vice versa, right? So these are the 6 factors. And today, what I wanted to spend my rest of my time on, rather than going into particular techniques for addressing these different factors, I just wanted to give some anecdotal evidence that these are to quite an extent interrelated. So trying to address one factor, quite often you have to deal with another 1 or 2. I would say that at Cogscale, actually, we came up with this pie chart, well, excepting for the performance piece, the other 5 pieces, about 3 years back. And now I see a lot of companies pretty much coming to some sort of combinations of these 5, with a few exceptions. So for example, Microsoft also has accessibility as a criteria, because they come up with products and they want to see that products, for example, new kind of mouse, should be accessible to all sorts of people, people who have 2 left legs like myself. So all sorts of people with disabilities also should be able to access such products. So that's very, that's something which is fairly peculiar to Microsoft. But overall, I would say it's good to think about these 5 plus performance or business KPI as the guiding principles behind a trustworthy AI system. So this cartoon came in the Austin American statement last Saturday or Sunday, one of those 2 days. And this actually talks a lot about how we think about fairness of AI systems. So you can see, just in terms of words, there's talking about housing bias, unfair lending. So there's bias, there's fairness or lack of it. So when you think about fairness, of course, you want to think about, who are the people against which we want to assess fairness. So in our jargon, that's called the protected attribute. So that could be race, age, gender, combinations thereof, and so on. So in this cartoon, I guess that's actually representing a particular protected attribute. And that's an attribute that's basically used to stratify your population and then compare the impact of your model to one subpopulation versus the other subpopulation. The other thing you want to think about, of course, is the outcome variables. So here, maybe it's the outcome is whether you decide to give a loan or not. So these things, or whether you do stop and frisk or not. So those are the outcome variables. So those are the 2 easy parts to the problem. The difficulty is how do you actually measure fairness? And in fact, there's no one measure, and IBM right now has a repository. They have over 70 measures of fairness. So the fact that there's so many of these existing, means that there is, there are different situations need different measures. But that is a problem. So for example, you might say, well, people in each subgroup should have the same probability of being stopped and frisked, but maybe some subpopulation is just more likely to, do crime. So in which case you say, maybe they should be stopped more often. But then the question is, well, if so, then how much more often? So when do you think it's reasonable? And maybe there are other reasons of why they're more likely to carry a gun. So now you have to figure how that or in general historical inequities or historical reasons might come into play. And then, of course, there's a whole question of mitigation. And we've done work in both these aspects, the evaluation and mitigation, but that's another story for another panel. I also want to quickly mention that if you think about going ahead and thinking about reliable AI adoption and deployment, one of the things that's really lacking when, from the engineering side, when I looked at engineered products, a lot of them come with warranties, not even guarantees. They come with warranties. And certifications that are third-party verifiable. So I know that Ashley, our executive director at AI Global, is the moderator, I think, right, for today. Ashley, somewhere there? Yeah, but at AI Global, what we are trying to do is come up with an equivalent of this is very, very ambitious, and this will take a while, but something like the LEEDs certification process for certifying green energy green buildings, right? So the idea is that such certification will evaluate AI across multiple dimensions and come up with some sort of comfort that you can use it in your own products without getting into trouble, or much trouble at least. So I, in my own research, we mostly focus on algorithms. So for example, Certify is an algorithm that is used to evaluate AI considered as a black box, and it simultaneously evaluates bias or unfairness, provides explanations, mostly in terms of counterfactuals, and assesses for robustness. So, and turns out that all three are interrelated. Another paper that's going to appear in, so AIES is the AI Ethics and Society Conference, is one of the main conferences in our area. This is how do you design neural networks, like deep learning networks, which are simultaneously fair and robust. So these are very algorithmic approaches to building trustworthy AI. But this is not the only way. In fact, this is only a very narrow view of thinking about this problem. Another view would be to just give you a contrast. But another thing that's come up, I don't know how many of you have seen this, but I actually learned about it only 2 weeks back. And in the last week, I've only been reading papers in this area. This whole new emerging area of physics-informed AI, right? So if you're trying to predict things where there's an underlying physics, whether it's about soil moisture or climate or whatever, then there are already some known physical equations. Typically, these are partial differential equations. And then the question is, how can you use that kind of equations and other kinds of domain knowledge to influence the design of your AI system? And one of the things it does is it ends up in systems that are by design much more explainable because they incorporate what we understand about the domain, and much more reliable, much more generalizable, much more better at dealing with corner cases. So we're discussing about the Tesla that did not take the corner case properly, right? It missed the corner and went up in flames over the weekend. So this is, I think, a very exciting area that it's been really there for about 2 years, but in a different community. So this is something I've been picking up very recently. So I wanted to give you a quick final slide, just to say that there are other ways of thinking about trustworthy AI. So this is a slide from an article from Boston Consulting Group. So this is, they talk about the 6 steps of making responsible AI real. And when I read these 6 steps, none of them are about algorithms. They're all about processes, right? They're about leadership. How do you define, various corporate structures, training, and so on. So this is another very different, but, equally valid way of think about, how do you design AI products and consume responsible AI products as well. So I know I think a couple of people in the audience who are like chief ethical officers. So quite often you might be thinking at this level rather than at the algorithmic level where I primarily sit. Okay, so that's all I had to say for the moment. So let me stop my share and turn it over to Min. Right, are you next, Min?
Yes.
Yeah, great.
Okay, do you see my screen?
Yeah.
Okay. So thank you, Jyoti, for a wonderful presentation. And thank you everyone for attending the forum today and spending your precious evening with us today. I'm really excited to share with you some of the lessons that I've learned from working on a project where we aim to build AI for social good. And I've heard that Austin Forum used to happen in person over drinks. And obviously we cannot do that tonight, of course. So instead, I'm sharing pictures from some of my favorite outdoor breweries and distilleries around Austin here, so that we can pretend that we are having this conversation under beautiful oak trees. I'd like to also acknowledge that the work that I'm going to present today is possible thanks to amazing students that I work with at the UT Austin, as well as the funding from National Science Foundation and UT Good Systems. So our research takes place in three complementary threads. We seek to gain novel understanding of human perceptions of trust around AI and algorithmic decisions. And we also develop participatory method and system to empower workers and citizens to design AI systems for their well-being and fairness. And finally, we explore data science and AI explainability to design decision support systems to enhance human decision-making. And we conduct the research with the goal of creating more just and empowering workplaces, cities, and online environments. So the lessons that I'm going to share today is from our experience in working on these projects. You might wonder why we need to care about human perspectives on AI fairness and transparency at all. Like, can we just use fair algorithmic techniques to build fair AI? Well, I'll say the answer is no. As Joydip mentioned, nowadays, many definitions and metrics of fairness, AI fairness already exist. And it would be great if you can just implement all these metrics to make it ultra fair. But existing research suggests that actually these AI definitions are not compatible. So someone needs to determine what fairness definition needs to be used for their own context. Additionally, existing real-world examples suggest that people will reject AI even when it is effective if they think it's unfair. So for example, in Flint, Michigan, the city built an algorithmic tool to predict which houses are likely to have lead pipes as one way to improve the city's water quality. And the algorithmic system was 70% accurate in the real world, but the city residents started pushing back the use of algorithm because they thought that it was unfair to use an algorithm. So they demanded that the city should just start digging up every house instead of using the predictions. And then actually their accuracy dropped to 15%, meaning only 1 or 2 houses out of 10 houses they did a construction had lead pipes. And one might wonder whether this phenomena about AI is new. And then my answer is also, again, no. It is, in fact, it's well known that the procedural fairness, which is the perceived fairness of the decision-making process itself, plays as important role as the actual outcome distribution or an outcome in how people judge the fairness of the decisions. And there has been a long line of research that shows this phenomenon in the field of organizational behavior, psychology, etc., and how people perceive government and police and law enforcement system, etc. So our work investigates how to introduce this procedural justice in the way that we design and conceptualize AI fairness. So we investigate how to explain AI decisions and give control to people. And we also explore how to incorporate stakeholders' concepts of fairness so that AI systems are not built in silo based on any engineers' assumptions, but are co-designed with stakeholders so that principles coded in the AI systems are in line with the stakeholders and communities' priorities. So today, I'd like to highlight the things that you can keep in mind when you aim to build a fair and transparent AI. So based on our experience, I argue that you should first understand what your stakeholders think is fair. And then, depending on your application, you should also consider working with your stakeholders to design the AI. So let me go through these points in turn. So to support the first lessons, I'm going to share some examples of why people think why people might think AI is unfair. And I'd like to start by asking a question. So imagine that you're applying for a job at Google, and you later find out that your application was reviewed by an algorithm only rather than a person. So how would this knowledge of the decision maker influence your perceptions? Would you feel that hiring decision was fair or less fair? And here I cannot do the raise hand, etc. But you can kind of think about your own answers. So to understand actually what a majority of people think about this decision, we conducted an online experiment. And we learned that actually for hiring decision and evaluation decisions, regardless outcome, the fact that the knowledge that people have that the decision was made by the algorithm instead of human had a significant impact on how people thought that the decision was fair or not. So they thought that the algorithmic decision was less fair, less trustworthy, and evoked a more negative emotion. So one reason was a lot of people thought that the algorithm just lacked human knowledge and intuitions that are important to making hiring and evaluation decisions. And people did acknowledge that algorithm can be objective, meaning same process is applied to everyone, but their concern about accuracy overshadowed this consistency. The other interesting finding is that these algorithmic decisions about human itself seem to evoke negative and sometimes dehumanizing emotions. So for example, one of our participants said that he would feel like a machine being chosen by machines. So the fact that people are or can be evaluated by the algorithm would seem to have a demeaning effect on workers. So we were really curious what would happen if we tell people more about the algorithm. Maybe one reason why people thought that algorithmic decision was unfair was because we didn't tell people that we apply some kind of fairness guarantee. So we conducted an experiment on using fair division algorithm, which divide the goods or resources in following some fairness principles. And in the experiment that we conducted, we also learned that even if we say people that we use fair division algorithm, not many people actually thought that the decisions were fair. And one big reason was that the algorithm embedded or embodied one concept of fairness, which was equity-centric and used one input data, which is individual preferences, whereas people had just diverse concepts of fairness and they wanted to use a lot more diverse utilities. So instead of equity-centric fairness, some people just wanted to have a more equality-centric fairness. And they also wanted to not just use individual preferences, but use other factors. For example, it can consider individual skill level differences in the way that it divides resources, or maybe someone's needs. If someone has more needs, they wanted to give more resources to them. And the way the fair division algorithm was implemented for goods division, it was not just accommodating these different groups norms. So I just explained why it's important to understand what your stakeholders think is fair so that you can choose AI definition that fit your context. And another way to build a fair and transparent AI will be to open up your design process itself to the stakeholders so that you can design your AI systems by working with the diverse stakeholders. So I'll give a quick example using a framework that we designed to build a matching algorithms. So in our work, we propose a framework called We Build AI. So in this framework, the key idea is that individuals build a computational model that represent their each stakeholders, and then this model negotiate or vote on that individual's behalf. So this works like a group of people making a decision together, but instead of an individual, like virtual computational model of each individual, we'll make a group decision for each algorithmic decision. So I'm going to show a case study where we apply this framework. So we work with a nonprofit called For On to Food Rescue. And this is a kind of a work organization that's like Uber for charity. So they take donations from donors such as grocery store, and they allocate them to a nonprofit that help food insecure communities. And they have an app like an Uber so that they can recruit volunteers to actually transport donation from the donors to the recipients. So this organization wanted to introduce algorithmic allocation system because a few human employees were overloaded, but also their donations were quite skewed because humans are making these allocation decisions based on their memory. So 20% of their donations was actually going to 70% of their donation was going to 20% of the organizations. So what we did is we worked with the stakeholders, volunteer, recipient, the organization and donor, and we use our frameworks. So first, we kind of talk to the stakeholders to determine what information should be used for this allocation algorithm. Then we work with the individual to understand what they think is an ideal matching. So in one method, they actually train their algorithm by using pairwise comparison method, or they also use this kind of explicit rule because we are working with a non-programmer. So we wanted to kind of create a way for them to create algorithms. And we show the algorithm they built in this kind of visual model. And we kind of, and then ask people to choose one that best represent their decision making. And once our stakeholder chose the model that they think best represent their kind of matching decision, we implemented these individual model into the system so that whenever incoming donation is coming, whenever there's donations, this individual model, computational model, create a ranked list of potential recipients. And then we aggregated those lists using a voting rule to create final recommendation list. And finally, we explained this decision to the stakeholders and then built the decision support tools for the organization itself. So we don't have a time to go through the kind of findings today, but hopefully this was one example where you can work with stakeholders to determine what should be used for your AI, and then how the trade-off between, for example, efficiency and equity in donation distribution can be made. And before I close, I wanted to also share further resources. If you're interested in kind of human-centered approaches to building fair, responsible AI, or explainable AI for fairness and social justices, we've ran 2 workshops on this topic, and you can go visit this website to see interesting work from around the world. Thank you.
Okay, is that visible, somebody?
Yep.
Yep, okay, thanks. So I'm up last. I apologize for the somewhat text-heavy presentation, but I wanted to talk about some sort of abstract issues rather than some of my recent research. And so I titled this talk, The Relationships Between Fairness, Interpretability, and Explainability of AI Systems. So these are all terms that people have talked about, and several of the previous speakers already talked about how they're sort of difficult actually to define a lot of these things. And I'm just going to present a quick summary of what I think is a sort of accepted a reasonably common definition of each of these, but then I want to talk about what I think is more interesting, which is the relationship between them. So fairness, again, we've had several discussions of that so far. So here I put a question for each of these. Is the system more likely to make errors on certain categories of cases that may lead to discrimination against protected classes? So these are a couple of very well-known cases that have come out in the media. Facial recognition systems are more likely to make errors for people of color. There's this famous case of a system that predicts recidivism, or rather a crook will repeat crimes into the future, and it was found more likely to incorrectly predict that African Americans will reoffend, and those are used in decisions for sentencing and parole, and can have very negative impact. So there are a variety of solutions to try to make AI systems more fair. I just listed one here, which is to try to ensure that the predicted error rate is equivalent across some set of protected classes. But again, fairness is a large topic in and of itself. So interpretability, there's a little bit of different use of the words interpretability and explainability within AI, but I think I'm picking one here that's sort of the more accepted use of these terms, which is interpretability is whether the overall process by which an AI system makes decision is understandable by a human. And the standard reaction these days is modern AI systems are based on deep learning that are these opaque black boxes. You hear that phrase all the time. They use very complex mathematical formula with literally millions of parameters to make decisions. And people really don't understand what are these models doing. So there are a variety of approaches to trying to understand what these very complicated deep neural net systems are learning and doing. So one is to just abandon and say, we don't want to learn those sorts of impenetrable systems. Let's learn more interpretable models, just like if-then rules or decision trees or linear models. And this goes back to a sort of older era of machine learning, but a lot of times those models are not as accurate. Another approach is to try to take a very complicated model and then extract a sort of simpler, more interpretable model from it that at least approximates the decisions of the more complicated model most of the time. So you can try to find these more extract versions of these simpler models from the more complex black box model. And another part is to say, well, the whole system is never going to be totally interpretable. So let me at least try to find subparts of this complicated model that seem to detect human interpretable concepts. So one of the earliest that I remember was back in the 80s, when Joydeep and I first started working on machine learning, there was this famous system called NetTalk that taught one of the old neural network styles of backpropagation to convert text to speech. And the researchers found this hidden unit, this sort of neuron in the middle of the network that detected whether a letter represented a vowel or a consonant. And they could actually see that node is detecting one interpretable thing, and then maybe get a little idea of how that would be helpful to interpreting how to pronounce that letter or not. But we're not really getting an interpretation of the whole overall model. Explainability, on the other hand, is typically used to refer to is a specific decision about a particular case made by an AI system understandable. So we want the system to provide interpretable rationales or explanations for why a complex AI system made a very particular conclusion. I'm not trying to understand the model as a whole. I'm just trying to understand why it made this very particular specific conclusion. And again, there's a variety of research out there. I literally was just today, in the next couple of days, I'm at this DARPA conference on explainable AI, which is the wrap-up of a DARPA program that's been going on for the last 3 years. And there's a lot of different work going on in that program and in the community broadly about explainability. One approach is to sort of give the primary features of the case that supported the decision. Another one is to particularly used for images, is related to produce a so-called heat map that sort of shows the part of the image that most influenced the system's decision about that image, where the sort of hot part of the image is the most influential on the decision. Another approach, my research these days is mostly in natural language processing. And another approach is to produce a natural language, like an English explanation that justifies the decision of these complicated networks on a particular case. And then another thing is to give a simple, more interpretable model, a lot of times a very simple linear model, for those familiar with that term, that approximates the system decision, but not for the whole space, but just for the examples around that particular case. What does the decision boundary look like? And how is it making decisions about examples like that particular example that we're interested in explaining the decision of? So I've been doing some work, particularly on multimodal explanations, that try to combine some of these approaches. So I just have a really quick example here of something we've done recently, which is combine both a visual and textual explanation to justify answers to a visual, what's usually called VQA, visual question answering. So I get a question like this: what is this person doing in this image? And the answer is skiing. And one way to try to build a system that can build explanations is to ask people to give explanations for their decisions. So this work that I'm referring to here used crowdsourcing to collect multimodal human explanations. So this isn't from a machine, this is from a human. They've given you this textual explanation because he is on a snowy hill wearing skis. And we've asked the user, and they've highlighted these particular part of the image, the ski poles and the skis that support that decision. Then we can use that data to try to train them algorithm to try to justify its conclusions. And we did something similar to that. And here's just one example. This is actual system output of it. Look, gets this image and it asks what type of room is this, and it says it's a bathroom, and it generates this natural language explanation. There is a toilet and a sink, but it links the terms in that to detected objects in the scene, and it highlights the toilet here in red and the sink in blue. So there's sort of a connection between what is the heat map, sort of much more detailed segmentation of the image about the objects that it's detected that support its decision, and then give a natural language explanation using that. I just wanted to mention one other interesting part of explainable AI is that a couple of years ago, the European Union passed this thing that I'm sure a lot of you are familiar with, the GDPR, the General Data Protection Regulation. And one part of that, the so-called Recital 71, is called the right to explanation, that says that consumers in Europe have the right to have their decisions explained to them when some automated decision is made about them. And I'm not completely sure all the approaches that companies have tried to use to satisfy this and what sort of lawsuits there are out there on this. But it turns the sort of what I still consider a research problem of explainable AI into an actual legal issue. The thing I wanted to bring out as sort of the focus of my talk is, okay, these are three different aspects of building, sort of ethical and transparent, fair AI systems, but they've largely each been studied by an independent community. I think our previous speaker referred to a little bit of how they really are interdependent. There's been a little bit of work on trying to understand the relationship between these three things, but I think it's largely an open question how they relate to each other and how we can do research that connects them. So particularly, I look at each pair here. Let's look at fairness and interpretability. If a model is interpretable, well, then we can examine it. A human judge can look at the model and see, is it using inappropriate or inexplicable features when it's making decisions? So say we have a recidivism predictor. It seems like one of the main features that it's using to make its decision is the zip code of the person's residence. Well, it might be defensible, but on the other hand, it might be a proxy for their race, because obviously certain zip codes are very prevalent in one particular race or not. So we might want to look into that, because it's a sort of an unusual feature to be using, say, for recidivism prediction. So a broader question is, how can an interpretable model be automatically inspected to determine if it's using a fair process to make its decision by some reasonably precise definition of fairness? And already several speakers have referred to, there's a variety of those out there. The other is fairness and explainability. Obviously, if a model is explainable, its explanation for a particular conclusion can be examined by a human judge to see if it's using inappropriate or inexplicable information. So there I see a particular person that has been denied, say has had a very large sentence or been denied parole. And then I see that, oh, one of the main features it's used in making that decision was their zip code or something. And I might wonder, well, why is it looking at their zip code to decide whether or not they should get parole or not? And I might want to look into that. So the whole idea of fairness and explainability is a system should not just be accurate, it should be accurate for the right information, for the right reason. So there's this phrase that is pretty common within the explainable AI literature, which is right for the right reason. We want AI systems not just to be correct, but to be correct for the right reason, because only in that case can we guarantee that they'll be robust and fair. And then finally is the relationship between interpretability and explainability. If a model is interpretable, it should be possible to easily extract an explanation for its conclusion on any particular case. If I can understand the whole model, I can hopefully pretty easily produce an explanation of why it made a particular decision. On the other hand, a little less clear, if a system is explainable and a person examines the explanation of a large enough diverse sample of individual cases, and I look, well, how I made this decision, how I made that decision, how I made the other decision, maybe by looking across all of those explanations of a wide variety of diverse cases, I get a little broader impression of what is the overall process that it's using to make conclusions in general, therefore hopefully making the model a little bit more interpretable. So I end on, everyone knows me knows I love to recommend books, so I'm just ending this on a book that I do pretty highly recommend, a recent book called The Ethical Algorithm by Mike Kearns, a very well-known learning theory person, and Aaron Ross. The subtitle is The Science of Socially Aware Algorithm Design. It's meant for a more broader population, although it's a little bit technical, but I definitely recommend it. So just to wrap up my part, people have talked about these different aspects of ethical or transparent systems, which is fairness, interpretability, and explainability, but they're all a little bit, people use them in slightly different ways and they mean different things. And I think an interesting problem is studying the relationship between those different aspects. Okay, I'll stop at that point.
All right. Matt, did you have any closing comments, or are we ready to go to the final slides before Q&A?
Go ahead.
All right, thank you guys very much. That was really interesting, and we are going to get to Q&A about that in just a bit. Before we do that, we have just a few final slides, so hold on one second.
Do we want to welcome Ashley while we get to the final slides or afterwards?
Well, we're going to do that. We have a slide that welcomes her.
Perfect, perfect.
All right, so first I want to, is this sharing now?
Yes.
Great. I want to thank the Good Systems Project. It's a UT Grand Challenge project. I put the URL on the bottom here. They sponsored this event tonight. They provided all of the speakers for it. So please check out that URL. I see I got a slightly pixelated version of the image. I'll update it in the final deck to one that has a little bit that's based on vector graphics. And want to thank all of our sponsors again. They really make all of this happen. You'll recognize some of these companies on here are AI companies or make products or solutions for AI, but all of them care deeply about technology and society, both local companies and national and global scale companies, and they really make all this happen. And one more announcement for me, I'll turn it over to Jessica. Tonight, of course, is the AI Fairness and Transparency event, and we are not done yet. We have Ashley Cassavan from AI Global, who was just mentioned in the slides about 15 minutes ago. She is going to moderate the Q&A from 7:30 to 8 o'clock. But we also wanted to tell you that we have an AI and Whiskey Chat. That's the next event, and an Intro to AI class. And then we have a lot of good events coming up. On May 4th, Smart Cities. On May 18th, Immersive Experiences. Blockchain and Bitcoin are 2 events in June, and then some other great events coming up the rest of this year. Whoops.
Yes. And we invite you to help others get connected now, even as the world emerges from the pandemic. We have partnered with Austin Pathways. They're an amazing local organization. So especially if you're in Austin, I know we have people from all over right now. There are residents in Austin who need your extra devices, that extra iPad, that extra phone, that extra smartphone, that extra computer. Austin Pathways will come and get it safely from you, safely refurbish it, and deliver it to local residents in need. So please, you'll get this information. It's also on our website. We've donated lots. Our amazing community has donated lots of devices. So please help. And we invite you to learn, share, and discuss us. Please share. We have a lot of great upcoming events. Please share about them. As Jay mentioned, our marketing budget is a big goose egg. So we invite our community has continued to grow during COVID because you guys are amazing. So please help us out, share about it on the Twitter, the Facebook, the Slack, the LinkedIn, the everything. Oh, and my favorite question. So in the chat, before we get to official Q&A, we have lots of 70 friends still with us, more than 70 friends. What's the best thing you learned tonight? So put it in the chat. You guys did awesome sharing what magical powers you wish you had through AI earlier, what you wish AI could do. What was the best or most interesting thing you learned tonight about AI? I thought there was, Jay knows I'm always a sucker for anything that talks about social impact and social justice. So hearing those things, those are really exciting for me too. So I want to see some answers. I know that we got lots of people still here. What's something interesting you learned tonight? Oh, you have 30 seconds. And we invite you to share about it online, share about it on Slack. We build AI, intrigued by the LEED certification framework, the clarification of interpretability, fairness. Oh, see, now all of it's coming. People are thinking about ethics. Absolutely, Boris. I'm glad that you're realizing that. It's something that we've talked about in a lot of our AI events. Your ideas on AI are as good as the best researchers. Well done, Fred. We're proud of you. Good job. So thank you.
And we have another event coming up next week that we want to tell you about. We have an AI and Whiskey Chat. Matt Sanchez from Cognitive Scale, one of our advisory board members, and I will host this. Everybody is welcome. This is a smaller event, so we don't do it in webinar format. We do it in meeting format so that everybody can be on screen, share their whiskey as well as their thoughts on AI. You can be a novice or an expert and attend. Man, I'm kind of counting on you to attend based on that first slide you had in your presentation. So I hope you can make it. It's 7:30 on Wednesday of next week. There's a web page on our website for it, so it'll be listed as the next event. by tomorrow when we update the website. So hopefully you'll be able to attend that.
And this is the first event that we've had our own little logo going on. And so we're very pleased about that. So all the more reason to come and toast the new logo. So yeah, we'll be back really fast. I think even like 2 minutes for
2
our
minutes.
live Q&A. We'll have Ashley's been going through the questions. We'll have an opportunity to bring you, especially if you're here, bring you on camera with our fabulous, fantastic, brilliant panelists. So grab a quick drink. Jay will go to his whiskey corner and behind his shoulder.
And Ashley, thank you for joining us. I hope people got a chance to see Ashley speak in the event last week. She's so on point with tonight's topic. In fact, she was mentioned in tonight's topic, and we want to bring her back for our podcast as well, but we asked her to moderate tonight's Q&A. She may slip in a question or two of her own in there, but she'll be calling on a few of you, and Jessica will then promote you to ask your question live. So 2 minutes.
I can hear Jay's 2 minutes there. Oh, perfect. Wonderful.
All right, are we ready? I'll stop the share and we can put all the panelists in gallery mode, and we encourage you to put everybody in gallery mode. Welcome, Ashley.
Thanks so much for having me. Happy to be back this week.
Having you back, yeah. And we're going to get you on that podcast sometime soon too, so be warned. But don't worry, your workload gets easier and easier each time. From presentation to moderation to podcasting gets easier.
Sounds great. I know we don't have too much time and there's tons of questions, so I'd love to get to them. But happy to be here, and it was great to hear even just the tail end of the presentations, and familiar with most of the panelists, so really excited to hear the answers. I think that typically in these conversations, especially as we're talking about heavy problems like ethics and the challenges or unintended consequences of AI systems, it might be nice to start with a positive question. So I'd love to call on Rohan Mathur. I thought that your question was really interesting. So Jessica, if you could put him or her forward. Then.
Yes, them.
We love Rohan.
Yes. And you might need to, we let them dialogue with their people if they're so inclined, but you might, sometimes they can't see their own questions, as we realized tonight, Ashley, as we were troubleshooting. So sometimes I've had people be like, I forgot what I asked. And I'm like, no worries. So Rohan, are you?
Yeah, Rohan, if you don't know your question, I would be more than happy to read it, but it is quite lengthy, but I think a great question.
Yeah, I actually don't have the question in front of me. So if you wouldn't mind reading it, it probably captures it better.
Sure. Has there been any work done on types of social problems that may be solved by AI that with a high level of confidence will not have an effect on bias fairness? I'm thinking, for example, an AI that could increase the amount of funding that a social services organization receives. Even if there is inaccuracy, there might not be questions about fairness. But the use of AI could still indirectly be doing a lot of good by optimizing the amount of available funding. So I'm wondering if there's any work on classification of these types of problems so that when working on a problem, people can be confident about using AI techniques and not worry as much about the questions of fairness, even though, of course, they will always have to be considered to some degree. Min, not to call you out, but I know you work on really interesting social impact opportunities for AI. And I think this idea of needing to evaluate responsibleness and ethics, even in kind of social positive AI systems, might be right up your alley.
Yeah, I can kick off the discussion, though definitely I will not be able to give the answers. So first of all, I think that any system cannot be bias-free. It will be always biased. Sometimes it could be desirable bias, but I think the reason why we care about this is how undesirable and harmful the bias is embedded in these AI systems. I was trying hard to think about where fairness or is less of a concern. And one application that came to my mind was, this is a scholar at CMU where she tries to build predictive algorithm for illegal hunting of elephants. I hope I was right, but then that one I was thinking maybe there is a less concern of bias. I'm not really sure, but still that was one application that came to my mind. But overall, I think it would be really hard to think of an application where there is no concerns about fairness or biases, because there's always an unintended side effect. Yeah.
Thanks. Matt, I see your hand up.
Yeah, just sort of a related comment. So I always like to remind people who forget, the first computers were people, right? It wasn't until we later built these boxes that could do some of the stuff. They were actually called automated computers, or ACs at first. And that was, originally the first definition. So when we think about computation or properties of computation, I think in general, we want to decouple it from who's doing the computing, if it's a person that's doing the work or a system doing the work. So when we took at, say, automating some tasks that people have done traditionally, I've had people yell at me in meetings that there's no way a machine could ever do that, because they're sure that a person has certain properties that has to do that work. And now we're sort of talking about the other way, like we're trying to talk about, well, what's the fairness of this algorithm have? But the question is, what's the fairness of the computation that you want done? So I think when we talk about these issues, we shouldn't really be talking about, can a computer be fair or can a computer be biased? But for the particular process or computation that you want done, what does it mean to be fair and biased, regardless of who's doing the computing, a human who's doing it manually or a machine?
Thanks so much. Dr. Ghosh, I think I saw your hand up first. Go ahead. Then we'll go to you, Maria.
So I'll give a little mathematical pointer, because I also saw somebody asking about multi-agent reinforcement learning, which is very challenging. So it turns out there's a mathematical framework called collective intelligence. It's by David Walpert at Santa Fe Institute and my former PhD student, Khan Toomer. So the idea is every person defines its own utility and greedily tries to maximize the utility. So that person obviously should be happy. But certain types of problems, you can show that there is a global utility, so that if everybody is trying to work greedily, then the global utility is also maximized. So in that case, everybody wins. So it's very rare, but certain types of things you can actually formulate that way. And they've showed it in certain scenarios, you can actually do that. So for example, they got a best paper for designing an air traffic controller where you can guarantee that every flight is going to land up earlier, at least not later, than if you did not use this algorithm, and there'll be no accidents. So in some sense, I guess that's fair if you don't get accidents. So so that's a mathematical pointer to your question. I'm not sure if that was what you were looking for, but yeah.
Perfect. And Maria, because since we're not going to get to all of the questions, I see a question specifically for you that David Ruth has asked. And David, you have several questions, so we'll come back to you maybe to ask some of yours. But in one of them, he's asking about explainability in AI systems and how that's working to solve gender imbalances. And so maybe if that could be incorporated into your answer, we can solve both of those.
Yeah, I'm happy to just go ahead and jump into these new questions since I know we have a lot of questions and not that much time. I think that this question really gets to some of the points that Ray brought up of the intersection of fairness and explainability. And one of the results from some of the results from the literature in the past years that I've found most interesting and exciting are some counterintuitive results that generally what we want to think is, well, if we have explanations, this is one pathway towards fairness, because we can then know whether the machine is being unfair. And what some of this work has pointed towards is the risks of explanations in generating over-reliance. So there's two core elements that have been found that I find both very interesting. One is these over-reliance effects that explanations can have. And so when, just like with a human, when the machine gives us an explanation and it sounds reasonable, then we say, well, that makes sense. And so we're more likely to follow the recommendation, often regardless of whether the machine was right or wrong. And so I think that over-reliance effect can have fairness implications. And there's also some work on how can you fool people through explanations. And in particular, in the relationship with fairness, this is work that has been done by Hina Lakkaraju at Harvard and her collaborators that looks at how you can have an adversarial approach to explanations in which I give you an explanation that sounds very fair because I'm not talking about any problematic features or things like that. But in reality, the impact of the algorithm, for instance, disparities in the outcomes may be very large. And so I think that to that point in explanations and fairness, there's a lot of exciting work, I agree with Ray, in exploring that relationship and what type of explanations and what type of guardrails do we need so that they actually can be a pathway towards a more fair algorithms.
Thank you so much. Bill Kleinenbecker, you're asking a question specifically around bringing behavioral science into the AI system evaluation. Would you like to ask your question?
If I can grab him. Bill, oh, there he is. Bill will be thrilled. Bill comes. Bill. Letting him, it says he's rejoining as a panelist. We will see. It's always a surprise. I've been told that maybe we should let people know that we're about to bring him on, but I like the element of surprise.
We have forgotten to do that.
Camera.
We haven't done that successfusly in a year, so why should we start now? We
I
always
think so.
forget that.
The element of surprise, but then Bill, we put you on as a panelist. Are you nearby, Bill? He's definitely, if not, okay. Why don't you go ahead and ask a question? Yeah.
Sure. So his question was around the need to bring behavioral science into this area. And so looking at behavioral traits, which may affect the ethics and bias of data science, which some of you have spoken to in your last question, but also particularly around staffing teams. And then also when trait is known for the results could be presented to help understanding potential bias. So just pointing to areas of where I think behavioral science research, which Maria, you just alluded to, so I thought this is a great segue, can really help to understand some of the more mathematical features, Dr. Ghosh, like you've raised before, and how those work together.
I'll make a general comment that's not very educated while my more esteemed colleagues think of smarter things to say. So, I think there's a lot of concern right now that responsible AI is just going to be defined by computer scientists and tech companies. And so one of the thoughts behind the Good Systems Initiative at UT Austin as being a grand challenge across the university is that we can engage the psychologists, the sociologists, the philosophers to really help us think about these issues. So we brought together a panel of 5 faculty tonight. And actually the 5 you have here are still more technology focused from the audience we intended here for. But really, if you go to the university more broadly in this effort, we are really trying to make sure that we're informed by this broader group of science beyond that. So I apologize, we don't have a philosopher here in the panel for you tonight as well. But definitely, I think we don't just want the computer scientists defining for the world what responsible AI should be.
Thanks, Matt. Do any of the panelists want to comment on their interaction with some of their colleagues, given you're more geared to the technical streams?
Well, actually, many of the notions of bias are actually coming from humans. So we definitely need to understand behavioral sciences. And the first bias that comes to my mind is confirmation bias. So quite often it's the observer who's biased, you could say, and you need to understand that because eventually the observer is your audience.
Thank you. Maria?
Yeah, so this is something that in a project that I have with a collaborator who's a philosopher and a cognitive scientist, one of the things that we've been looking at is precisely this question of the diversity of the teams involved in designing the systems, and the fact that we often have these, there's this claim of, well, these can be a pathway for more fair algorithms. And one of the elements, one of the nuggets from that work that I just want to highlight is the fact that one key point there is considering the pathways through which the diversity of teams may have an impact. And so when you look at scholarship in diversity and in the epistemic impact of having diverse teams, a key element there is what are the pathways through which having a diverse team is going to have that impact. And so one of the elements that I think is fundamental there when we think about having more diverse teams as a pathway to having better systems is ensuring that the decisions that those teams are making, for instance, are the decisions that can truly shape a system. It's not about predefining the task, predefining the goals, and then having a diverse set of engineers training the algorithm that we already decided what was supposed to do. And so I think that one of the big lessons that we can take from research in organizational sciences and in behavioral studies is when thinking about diversity as a pathway to fairness, we really need to consider what are the specific pathways through which those benefits will come about, and making sure that we're embedding that in the design.
Thanks. Kira, so I'm trying to give a heads up in the chat for everybody. So Kira, I think one of the questions that I have too always is, we talk about these things in a very broad way. And so thinking about specific projects or specific ways in which these systems are being used is quite interesting. So Kira's asking about one specific experiment that was mentioned on the panel. Jessica, I'm not sure if she's still yet.
She is online. Again, this is my fun part of the time where it's a little bit of chaos theory, like what's going to happen next?
Yay!
Because the people who get online, yeah, everybody gets really excited when they get a chance to dialogue with the speakers. So,
and apologies, Matt, I saw your hand go up after I started talking, so I will come back to you after. But Kira, go ahead.
Hi, yeah, so I joined late, but I work in medical AI, and there's a lot of examples where doctors specifically don't like to be told that they're wrong, and so we'll often ignore machine-generated predictions that are built into different medical machines. So I was interested in, Min was talking about the experiment that they ran that involved stakeholders in the process of creating individual kind of panel style algorithm and then amalgamating that together, but we just didn't hear what the result was. Did you end up having a more trusted system, and is it still in use?
So the short answer is actually yes. And because there was our hypothesis that if they are part of the process, if they make design decisions, they will trust the decisions more. And that was true. But also I wanted to mention the interesting caveat that Maria also mentioned in kind of about explainability, that the fact that they was part of the design, and then one person even mentioned that they're in the beginning very skeptical. For them, it was very caring decisions that machine cannot do. But then after they trained their matching algorithm, it was making decisions that they would have made on their own. So they were like, now I wholeheartedly trust this algorithm. And so that was a good result, but also at the same time, there can be also its own bias because I made it, I trust it, which may result in over-reliance again. So I think there is an interesting kind of takeaway that we should be very careful about this potential side effect, etc.
Thanks, Min. Did anybody else want to add to that?
Maybe just related, there was this work in looking at supporting lawyers and some of the work they do with search systems. And when they asked them how effective they were at finding relevant information, they thought 80 or 85%. And the numbers showed they were something like 15% effective. And so there's a great assumption often that humans are perfect and not fallible in the way that a machine would be. And so that's one thing that often we have going into some of this work. And one way to sort of get around this, I think maybe as we were hearing about, is sort of design things in partnership. And so what was done really well in the search engine community, this is particularly for e-discovery and civil litigation, was to bring together the companies who are building the products, the researchers who understand the technology, and the lawyers who really are looking at the use case, and have the three groups come together and really think about designing something so that you sort of have the people who are the stakeholders involved in that from the ground up. So I think that's sort of one general design practice for addressing that issue.
And maybe just, I know, Boris, I'm going to get to you and David. Oh, sorry, Jessica, are they?
Oh, they're not on. So sorry, I just put, oops, I popped Kira back, but we can keep the conversation going. And you please ask their questions, but I won't pop them up.
Sure, not a problem. Then I can ask my own questions. So we'll come to theirs though. But I think kind of on these points, one of the challenges that we come across lots when thinking about what good looks like in terms of establishing some rules or standards around how AI systems should function is really thinking whether or not these machines should be better than what humans do. So kind of to these points of there's fallibility in humans, even with facial recognition systems, there's lots of research that's been done around humans only being able to appropriately recognize or identify people to certain percentages of in certain situations, and also that it worsens when it's outside of their racial or gender profile. And so just to all of the panelists, if thinking about this and context in your work, how do you want, or how do you think that should be resolved? Is the objective to eliminate as much bias and promote as much fairness as possible? How do you go about doing that or resolving these challenges that we have already? Everybody's so excited to answer.
That was a good question. Clearly, it was like, woo, everybody's got to think about that one.
I think we're just all so dang polite. Does anyone else want to jump in? Because I've already talked a lot.
I guess I'm not really a fairness person. I should have meant I'm really an explainability person, but I think there are a lot of cases where machines can be more fair and more accurate than people. And like I said, there are all these techniques that can actually more or less guarantee that you get equal error across different protected groups, and which we can't guarantee for people, that's for sure. I mean, there's all these results that show the judges, you can get them in the morning, they'll give you parole, but in the afternoon they won't. And, just people are incredibly biased. So I think being more fair than people, algorithms don't have that hard a problem at that most of the time, I think. It's a question of there's still always some lingering bias, and we'd like to get rid of it, as much of it as possible. So I don't think the goal is limited just to beating be as fair as people. We want to be a lot more fair than people.
Raymond, just before we go to others, being an explainability person, the same thing applies for explainability though as well. Do you think that, because typically we're asking people to ask questions post facto, like explain why you made that decision.
And people are notorious for giving post hoc rationalizations, right? They don't really know. We're all doing a lot of processing subconsciously. We don't know why we make the decisions that we make, and we certainly don't know why a lot of deep networks make the decision. But I think we do. There is more promise that we can understand, because these are formal equations that we can at least look at and examine. We don't have those equations for the human brain, at least yet. And so I think there is a possibility that AI systems can be more explainable and more accurate and more fair than people. I'm not saying they are now, and there aren't a lot of challenges, but I think, I'm enough of a computer scientist to believe that in principle, all of those is possible.
Excellent. Dr.
Yeah. Oh, I just wanted to joke that humans are very good at giving post hoc explanations, especially when the decisions are bad. So clearly AI should have a much higher bar than that.
Excellent. Maria, Min, anybody else want to join?
I think that there's one element there that is important to differentiate, and is the fact that the deterministic nature of the algorithmic decisions can lead to a certain type of harms that you don't have in human decisions. So there's a difference when we're considering the aggregate, that is, as we've all pointed out, there's the humans, we are biased, right? But when, for instance, if I'm looking for a job and some people have some biases, some people have others, then eventually I may find a job. But if we start having algorithms, if we have an algorithm that is being used by a lot of the big companies and it is exhibiting the same bias, there is a harm of people, a group of people being systematically excluded from the labor market. And so this deterministic nature versus these variants that we often see as negative in the human decisions, that is, well, one day you give me the correct decision, the next day you have no clue what you're talking about. These variants can mitigate some harms. And I think that that is an important element to consider when we're making this comparison. And the last thing I'll add, though, is that I think that this brings a great point, that is, when we're thinking about the fairness in algorithmic supported decisions, then it is crucial that we center the decisions and not the predictions themselves. And there's so many interesting questions and so much space for work in what type of tools can we build that improves the fairness of the decisions that the humans are making.
Thanks. Really important points. And I think it's challenging because of the capacity of machines. The bar continues to move. And why I was thinking of this is because of Matt's example. And there's a case in Quebec last year, actually maybe it's 2 years ago, where a suit was filed against lawyers that were doing a bunch of work because they chose to use humans instead of machine processing for a lot of their evaluation. And therefore they were charged for overcharging their clients because a machine could have done that instead of humans. So it's really whether it is recognition within like facial recognition, or whether it is using it for electronic processing of documents. I think setting a different standard potentially than we're expecting of humans, and that could be positive or negative in different ways. So I find that really interesting.